Everyone has heard about ice and water on planets. But even scientists didn't know that one planet consists almost entirely of hot ice and water, which is not just a fluid, but what's known as a superfluid. Thus, the fascination began with a planet called GJ 1214b. This planet began to attract attention from the very beginning of its discovery. This exoplanet, revolving around its red dwarf parent star, was discovered in 2009 in the constellation Ophiuchus and became the second known super-Earth. Super-Earths are a class of planets whose mass is greater than the mass of the Earth, but less than the mass of gas giants like our own Neptune. And this makes it possible to consider them suitable for the possibility of harboring life. GJ 1214b held the distinction of being the planet with the smallest semi-major axis among all super-Earths, and the smallest semi-major axis among extrasolar planets, together with WASP-43b, until April 2011. It became the second planet of which we managed to accurately measure the mass and radius, and prove that it is smaller than the gas giant planets of our solar system. This planet is a true find for scientists, as it is exceptionally suitable for study. The distance from its parent red dwarf star is quite small, and the plane of its orbit allows us to view its transit across the dwarf star's disk every 38 hours. That's the length of this planet's year, and it is relatively close to us, just 13 parsecs, or 40 light years from the Earth. This simplifies observation of the planet for us and increases the chance of discovering life, if it exists, on this space body. At this time, a sufficient number of planets have been discovered outside our solar system to conclude that super-Earths are the most common kind of planet in the Milky Way galaxy. This conclusion does not explain what the physical nature of a super-Earth is, but the discovery of planet GJ 1214b has enabled scientists to make serious progress in this direction. It has a diameter twice that of Earth and 7 times its mass. A question arises: what does this cosmic body consist of? Data on the mass and radius have unambiguously shown that this is not a gas giant, but they also reveal that there cannot be a lot of rocky material or metal there either. Scientists have suggested, rather, that it is a water planet with a small, solid core. It is a planet which has an ocean whose depth has not been measured and whose elements are unknown. It is assumed that the atmosphere of the planet is one of 2 types. The first possibility, the atmosphere consists of water vapor or some other heavy molecules. The second possibility, the atmosphere contains clouds at high altitude, covering what is on the surface of the planet. In time, the invisible planet revealed one of the most stunning secrets. Its theoretical temperature was calculated. The figures obtained vary from 536 degrees Fahrenheit if the planet turns out to be absolutely dark, and 248 degrees Fahrenheit if the reflectivity of the surface is similar to that of Venus. Initially, it was assumed that the mass of this super-Earth was comprised of 75% water and 25% rocky materials and iron. The atmosphere was presumed to consist of hydrogen and helium, with its mass at about 0.05% of the mass of the entire planet. But then, in 2012, astrophysicists from the Harvard-Smithsonian Center released a statement that the atmosphere is water. Or, more precisely, it is very dense water vapor, the helium and hydrogen being just a small admixture in this mass. This new hypothesis was based on Hubble telescope data. They studied the change in the radiation spectrum of the star as it passed through the planet's atmosphere. In the scientific and academic world, the planet became known as the wettest super-Earth. It would be quite easy to work as a meteorologist on this planet. You can never go wrong with the forecast. Today, it's cloudy. Tomorrow, cloudy. Next week, cloudy. And so on, and so on, and so on. But the most amazing conjecture by these scientists was something else. As the surface of the planet has a remarkably high temperature and pressure, the water on the planet is not in ordinary states, but exotic ones. These states are called hot ice and superfluid water. Such states do not exist naturally on the Earth, as there are no such physical conditions to create them. But some abnormal types of ice have been experimentally obtained, and more than 10 states of ice were already known to Earth science. They differ in the structure of the crystal lattice of water molecules and are obtained at different temperatures and pressures. Hot ice, for example, at high pressure begins to melt only at 212 degrees Fahrenheit, and superfluid water is produced under terrestrial conditions by adding a small amount of a silicone organic polymer. At certain temperatures and pressures, such water is virtually devoid of friction and spills out spontaneously even from upright containers. The composition of the planet GJ1214b could consist of such ingredients. New, even more accurate studies of the space object were carried out in 2014. And again, a paradox. Instead of confirming the hypothesis of scientists, this water world spawned new riddles. Scientists not only couldn't find the supposed elements of the atmosphere, they couldn't even find a trace of them. No molecular compounds, neither water, methane, nitrogen, carbon monoxide, nor carbon dioxide were detected. There are clouds, but it wasn't possible to establish what they consist of. From the point of view of other models of super-Earths, the clouds could be potassium chloride or zinc sulfide, heated to 450 degrees Fahrenheit. One researcher of this planet, American Laura Kraidberg, argues that such clouds should have a completely different appearance from those on Earth. A new hypothesis has been advanced, that the state of the cosmic body is in its later stages, and that the old planet has, over the few billion years of its existence, lost a large number of its volatile compounds and is no longer in its original primordial state. Most likely, she was born far from her cold-blooded dwarf parent star, in severe conditions of eternal cold and frost. Then, the celestial body left its native orbit and was gravitationally captured by the red dwarf star. The warming up of the planet and its ice, as well as the formation of the superliquid water that enveloped the planet with its impenetrable cloud, began only at this point. So, when will we be able to see everything? This may happen quite soon, with the launch of the 21-foot James Webb Space Telescope. It will peer through the clouds of super-Earths like GJ1214b and finally see what they are hiding. And as soon as this new, interesting information appears, we will report everything to you. That's all for this episode. In the next space episode, we will tell you about something really very, very dark and mysterious. By the way, you can always speed up this process. The rules are simple. Type a MoreSpace hashtag in the comments and I'll do it more often. See you soon, my dear friends.